Check. Ooh. Hello, 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 hello. Wait a minute. Hello, hello. Hello, hello. Ah, shoot. Hello, hello, hello. To my microphone. Hello, hello. It's not fun. Okay. Test speaker, test everything, test. Okay. All right, welcome back, everyone. The afternoon session is going to be about SQL. It's going to be about database management. Well, it's kind of like, in theory, we are supposed to put our database management system after the spreadsheet sessions, but you don't want to have a whole day of Python codes. And, so today, for the last part of the workshop, we'll be a little bit relaxed, talk less about codes and talk more about data again. All right, so everyone, please ensure that you download both of the things on your Etherpad right now. If you have done everything, put out a green sticky, or if you don't have green sticky, replenish it with the blue stickies that I have here. Put up your blue-green sticky when you are done with all the settings, setups, and whatnot. Right? Sorry? That will increase the browser size. But yeah, I guess. But everything that you see here is supposed to be on your Etherpad as well. So sign up onto the Etherpad. Sorry? It's the same thing. Yeah, it's the same thing. Yeah. If you haven't downloaded the browser yet, which is the same one in the websites that we set up. Now, I would want you to have a look at the CSV files in the data files that we downloaded. Say, yeah, have a look at surveys, which is the, oh gosh. Some technical problems. Give me some time. Go away. Never mind. Sorry, it turns out that I have to download it. Oh. Okay, so we'll have a look at the combined.csv. All right, we have been using the same data set throughout the whole workshop. These sets of data is again the same ones. And if you look at the same folders, you also see surveys.csv, plots.csv, and species.csv. that is one way. We have three data tables. And then we have combined.csv, which is essentially combining the three tables into one. So now you see that you also have an additional column of genus and species and taxa that is originally from our species.csv. If you go down, you see many of the same values because they are all referring to the same species NL, the species ID. So these three cells would share the same value as the NL here. And then the last column, you have plot type, which is actually part of the plots.csv. And they kind of describe the plot ID that we have here. Now, why do we ended up working with three data table? Why don't we just have a combined.csv like that? Okay, a super table with all this information here. Any suggestions? Which one would you prefer if you were to do your data analysis? What are the pros and cons of using a combined data table like that? Well, the pros of having a combined data table like that is, first of all, I only have to deal with one CSV file. And if three is a little bit too much of troubles, one is just fine, you know. And there's additional 4 columns in this data table. So if you look at the probably, well, basically for the combined table, we are dealing with larger tables. Okay, so what we used to be is the first, I think, 9 columns that we have up to the weights. Now we are dealing with 13, 9 plus 4, 13 columns of data. So one of the good and bad thing about having a combined data table is that you're now dealing with a larger table. And if you imagine that we have hundreds of thousands of rows, and then maybe there are more and more information, we pack in more and more information towards your right, what will happen is that we now deal with a huge spreadsheet table, or we now deal with a huge CSV table. And it becomes harder and harder for us to know, like, oh, where are the columns that we are looking at? Which rows are we looking at? Right now, we are looking at about 13 columns, so it's fine. But you can imagine that as your data gets larger and larger, when you have more and more attributes on your observations, this gets harder and harder to manage. And that's the reason why we have three data tables separating putting off some of the informations away. Now, another additional advantage of having 3 small tables instead of one big chunk of tables is that, say for example, we look at the species.csv. Now, as a biologist, I know that scientists or biologists love to change their species names. Okay, maybe 5 years down the road, someone published a paper and say, yeah, the Amphispiza balineata should be something else. And if we were to update our database, if we were using the combined data sheet, we will have to go through every single entries of the Amphispiza balineata and change the names accordingly. Whereas in this kind of format, in the 3 small table format, we have more flexibility because now we only need to deal with small tables, and we just need to change row 2 to the whatever updated name. And this gets, imagine if you're dealing with larger set of data. Say for example, we talk about in college, we have academic department, okay? So academic departments has our name. Let's say I'm the students. It has a student name, course that we take, and grade. Okay. And then say, for example, we go to the financial department. It also has student name and maybe money that I owe the universities or the college. And then maybe I go to another department. We have medical departments or student health departments. Again, we also have name. And we have, I don't know, whether or not I'm vaccinated. All right, so we have 3 departments. What happened if tomorrow I tell my universities, I'm changing my name. I don't like my name. I don't like that. I'm gonna be someone else. So the university will have to go to the academic departments, tell them to change my name in all the records in this particular data table. And then they will have to go to financial departments and do the same thing again. And then go to the medical departments and do the same thing. All right, and you can see that if you store all the information in one big table, you're gonna run into a lot of this issue. What if I want to update my names? What if I updated my name in academic departments and financial departments, but not somewhere else? Then we run into an issue, right? So how do we deal with this problem? How do we deal with this problem? Any suggestion? Well, we have student ID as well, right? That's why each of us have a number. So then we only need to create another set of records that has student ID and my name. All right, so for all the other departments, they don't need to know my name. They will just identify myself as a student ID, self-student name. And the name will store in one other data table. And so, I don't know, when I want to change my name, the universities can just update the name table. And all the other tables will not be affected at all. Because my ID is going to be the same. Okay, unless I quit the school and join again. Maybe there's some other issues that we need to deal with. All right, and the whole concept is what we call well, database. First of all, database is a collection of data table, basically. Yeah, nothing too glamorous about it. So say, for example, right now we have 3 CSV files, surveys.csv, we have plots.csv, and we have species.csv. 3 of them, we put them together, and they will be a database. But what's the relationship between the 3 databases? The 3 databases, at least when we look at the surveys.csv, ooh. Okay. The survey table is connected, is related to the plots table by plots ID. All right? And the surveys table is related to species table by species ID. Okay? So that is how the concept of relational database comes in. We have 3 tables storing different information, but the table that we want to work with, we only need some keys that connects one table to the other table. And that's why just now when we have, in the Python exercise, we do some merge table. We merge using some of this key, then we can combine the 2 tables together. we don't really need those information most of the time. We don't really need to know what are the plot types associated with plot ID most of the time. That's why we can chuck the plot table one side, put it somewhere. We don't really need to know, most of the time we don't really need to know the genus and the species name of the animals that we deal with. That's why we have a species ID here, and the species name, the genus, the species, and the taxa, what kind of animals are they, we could just put it away. So now we are dealing with a smaller table, and the system can allocate more resources into this table, into these 9 columns, as compared to when we use a combined table where we need to store 13 columns worth of information. And remember that, like, say, for example, in Python, when we use pandas to import the CSV file, we import the whole thing. Where does those things go? It goes into our RAM, or rapid access memory. Okay. So imagine if you were to read a larger and larger table, it's going to clog up our RAM, our memory more and more. So having a database like this, it can help the systems to say, okay, well, you're not using the plots information, you're not using the species information, let's put it back into the hard disk. Okay, let's put this information into our RAM. So it's probably the reason, one of the reasons why a lot of people were saying that, like, oh, relational database is a more efficient way of storing our data. That's because, like, the managers of the data, what we call DBMS, which is like database management system. So they are essentially the managers of our database, our data, can choose to allocate their resources differentially, and in some way making the searches and making the indexing much easier. All right. So over here, we already have the examples of how we partition our table out. I'll have a small, not very small exercise. I'll talk about this particular scenario, and we will work together, spend some time to look at how we can partition our tables, our information into different tables in such a way that we can build a database that is like more efficient in some way. And all right, let's see. You might want to go to your Etherpad. I'm copying and pasting all these things. Ooh. All right, okay. Now say I'm interested in the temperature, hourly temperature of 100 locations. And I'm not sure what loggers should I use. I have 10 choices. So I decided that I would buy 100 loggers for each of the models, or each type of loggers that I have. So in total over here, I have 1,000 loggers. So I go onto the site, I deploy each and every loggers on. So for each locations, I will have 10 loggers, all right, on each site. For each of the loggers, they have a unique identifier. They have a number or serial number. They have each of the loggers have their models, their manufacturer, and how much they cost. I have information about the 100 locations, the coordinates of the 100 locations. I have information about where they are, which county are they in, and which state are they in. And because the loggers is taking in data, so every hour the loggers will, okay, record what's the temperature right now, right? So there is a bit, loggers will come back with data with the date and time of the particular temperature readings. And during that period, whenever I log a temperature, I will also record the information about the battery. How much battery do I have left in this particular logger? And then I'm also interested in how maybe rainfall and wind speed has a relationship with the temperature. So I also pull information from the county weather station. And so I have the county level hourly rainfall that matches with the date time here. I have the hourly wind speed as well that also matches with the date time. I'm worried that someone might have deployed my data, my loggers wrongly, and I can't have one person deploying 1,000 loggers maybe within 1 day or two. So there are different batch of people, there are different groups of people who deploy the loggers onto the site. So I also have the information about the person, and I have their phone number just in case when something goes wrong, I can call them up. All right, I have all this information here. Let's take some time, think about how would we be able to, put them into data table. How do we want to organize this information into the a set? Well, hopefully a set of data tables. I don't think you want to do it in a combined table because you have 1,000 loggers out there. Every hour you are recording one data. That will be 24 data points per logger per day. And if it's a 1 month data, you can see that it's going to be huge sets of data. You don't really want to combine all this information into one big table. So is it possible? Think about it. How many data tables would you build to store this information? If this is part of your project for PhD, for masters, or for fun, how would you organize your data? Right? Maybe we can spend about 5 minutes, and maybe we can jot down what kind of table you want to build and how do you store this information. All right? Am I making any sense here? Okay. Yeah, write it down in a piece of paper, or you can fire up your notepad or something like that and write down you may have four categories or four tables, and then each table, what are the information that you would store in it. Sorry, is that it? Well, it looks like it. You want to turn it down?
Turn it up.
Huh?
Make it warm.
Make it warm.
Yeah.
So make it warm is turn it down.
How many of you think it's too cold in here? How many of you think it's too warm?
Okay, we'll turn up and see if it works.
Oh yeah. Yeah. So on this one you have these different types of. And then daytime. So it's between state and I can imagine where it's like I don't press the model numbers. And then maybe a separate one that's on battery.
Daytime is when the readings is captured. No, no worry, yeah. You can write
so
that.
you're saying like, oh, this person is the person who's responsible for the battery slow, we might want to send them. That makes sense. Or keep it with maybe also here. We can put it in multiple sites. So like you can put it here and here. Right. Like, I guess you can't see it all. So if in a situation where it's not working right, you're right, the battery might be low and you want to talk about it. Maybe you care. But then like, oh, the battery's low, here's the people about it, and then here's the problem. So like, oh, when you make that versus like, I just want to data, but I just want to know what's happening. I know. So I have spreadsheets that are like, like all my so like this is the problem I have. Like then you have crash. All the tabs. So like I see my database. It would be nice to have like a sample like I just want to use it. Here's like two, I'm sure. Maybe just only the one region. So I'll look at all of them. But then I'm wondering how it's here's like the sample, here's the way for somebody, here's the dissolution time, here's the dissolution, so then also has here are all of the different kind of policies. Because right now, we're like just one sample.
All right, let's try this out. Let's try this out. Okay. Anyone has any tables name that I can start with? Yes.
We said you might want to have like all your data together, so having rainfall, wind speed, temperature, location, date time, and the ID number all linked in one.
So that will be readings data,
Yes.
readings table, yeah.
Plus ID.
And then what do you want? Sorry. ID.
Logger ID.
Logger ID. And.
Oh, now that's a separate table. Just in that table.
As in like this is the reading table, and this is one of the components. Yeah.
You were saying
Daytime,
rainfall,
rainfall, wind speed, and temperature. That will be temperature readings. Okay. Cool. Okay. What other tables will you build then? Location
Yeah,
data? Okay, yeah, that's right. Location what?
coordinates.
Coordinates. All right, yeah. Okay, so then I will assume you have a location table maybe? Yeah, location table. By the way, there's no wrong and right about this, and you'll be, so we did some similar exercise, and you have every group's presenting how their database is gonna look like, and you have all sorts of different answers. Yeah. Location table. So what's inside location table?
Your logger ID.
Logger ID?
Yeah.
Oh. Okay.
Then location coordinates.
Location coordinates.
Countries.
County and state. All right. Yeah, more or less there. What else? What else? What kind of other information would we have to?
You could do a table of the manufacturer and price information.
Mm-hmm.
Something you always
Maybe like logger specification. Okay. Logger ID, I guess. Yeah. Model, manufacturer, and price. Okay, sounds good. We still have the name, the person deploying, who's deploying what, and the name, number. Do we have a new table for that, or?
And battery level.
Oh, and battery level. Where does battery level goes?
We said with the first step, because then if it's low, you can be like, hey, this check the battery.
So we have a person table, maybe. And this would be logger ID asking, and person name, maybe phone number, and battery level.
Then also maybe battery on readings.
If you have daytime, because you want the battery.
That's right.
At each time.
Yeah.
Right?
Yeah. The battery level is also recorded once every hour, right? Yeah. So there's like one first tables that we can, first group of first database that we built, and we can see how that all the tables are connected. In fact, all the tables have logger ID. So this is kind of like a web of 4 tables. So I would imagine that this table would be something like uh, 4 tables. They can kind of talk to each other. All by like logger ID. Okay. But any other suggestions? Like maybe we can reduce a little bit of redundancies, especially, for example, the person table. There's date time here. There is also readings table where the date time is. Maybe we can, I don't know, move the battery table up, battery level up here. Because if the person table has a huge, how do you call it? If the person table has the date time column, it's going to be huge because like there are a lot of date times every hour, in fact. So in that way, maybe we can reduce some sort of like a redundancy, not so much of redundancy, but we can reduce quite a little bit of size in our collections of tables. Right, it's not bad. I mean, it's a pretty good looking database. It can be that well, what is possible to move away? Sorry? As in in each readings. That would be huge, right? So say for example, we have a person name here, then we will have a lot of repeats of person name. So is that a good idea? Yeah, logger ID is yeah, because
Yeah, but now you use this person to some other project.
Isn't the person so long?
yeah,
So that's
the person is also responsible for the logger.
We could combine the person table with the location table without
Location table.
losing any.
Okay.
If you wanted to, I mean, because there's no, if you want to have a information table.
Yeah. Yeah. Now, like I say, there's no right or wrong, but this is what, in fact, the whole building of relational database is a very is a subject on its own, and I actually took a course on that. So, and there are some rules, but even with those rules, you will still come up with all sorts of different looking database. But it is important that we think about what we want, how do we want to build this database, especially when we deal with thousands of lines of readings. Because once the readings come in, 24 readings per day, I don't know, 30 times 24, 600 something, 720, sorry, per month. And then each and every logger is coming back with 720 readings, and your data table is just gonna be huge. And it is definitely not a fun thing to put all of this information into one combined table. In fact, I mean, I would also, you know, if necessary, I would also add a location ID here, because location IDs are unique to logger specifications. And then I have, I don't need a logger ID here. I can just connect it with location ID, and that would be fine too, for example. But yeah, so this is a little bit of an exercise, and to understand why we want to have database and why we want to have a relational database. A bunch of data tables will be nothing if it's not connected to each other. All right. So, and that is why that's how I start with talking about database. The thing about database is there are different. So just now I mentioned DBMS, database management system. Database management system is essentially the managers. We ourselves don't want to maintain the relationship between tables, so we ask someone else to do it. And the someone else is one of these systems. The common one that we probably heard of is like MySQL. MySQL has been used in a lot of web servers, for example. There's Postgres SQL, Postgres SQL, by the way. SQL also pronounced as SQL. Postgres SQL is like very commonly used in scientific research, for example. We have oracles. Some of these are more commonly used in the business communities. All of these database has some pros and some cons, and some are very good in handling resources allocation. Some can deal with millions of data without having much of an issues. The one that we are using today is SQLite. If we go to the file, the files, you can see that we have these things called portal_memos.sqlite. The beautiful thing about SQLite is that it's just this file. We can bring this file around, we can pass it around, and anyone else can access to the database that is stored inside this file. The downside is, of course, there's like security concerns, and also everything is stored in one file. You can imagine that when you have hundreds and thousands of lines of data, the files getting bigger and bigger and clogging up. And for some other database management systems, they would sort of like build these backend servers and something like that, and store the data table differentially. And that would enhance the resource allocations, storage allocations, and help with speed of data retrievals and whatnot. So we are using SQLite today as compared to, as opposed to like MySQL or PostgreSQL and whatnot. And all these database managers, unfortunately, they don't like to talk to each other. Okay, so there's another question of like, okay, when we choose, if we were to really build a database, who should we hire as our managers? Because they don't like to talk to each other. But the good thing is, we can talk to any of these managers with one language. There's the language that I keep mentioning. There's SQL. It's called Structured Queries Language. Okay, if you look at the name of the language, you can kind of tell that it's a way for you to ask the managers to produce something for you. The word queries. All right, we'll use the DB browser for SQLite to do our job. You can fire up the program, DB browser for SQLite. Okay. Okay, all good. All right, so we have a bunch of CSV, and we can actually import the CSV into using this little software, and we can actually build our database DB browser. I'm gonna do a little bit of demonstrations. If you go to import, oh, what happened? No, first we need to have a new database. So I'm gonna store it onto my desktop. Database, say for example, is called Portal. So the database has like SQLite database files. These are some of the extensions that you can see: .db, .sqlite, .sqlite3, .db3. Yeah, we can let the program to decide what extension they want. And then you can see that we have tables, indices, views, triggers. Mostly because this is a new database, we have 0 tables. And what we can do is we can go to file, we can import, we can go to table from CSV file, import the table from CSV file, and go to our data. Maybe I'll import surveys, for example. So once you have import the surveys CSV file, we see that the first row here is a bunch of attribute names. So you got to tick the column names in first line so that the DB browser knows that, okay, you're actually referring to these values as your column, your attribute names. All right, everything looks good. Say okay, and we import it completely. And we can do the same again on the other. But if we look in detail at the tables, if you click on the tables, there's like this drop down that you can expand. Once you expand, you can see each and every column that is associated with the table. And one interesting thing is the type is all in text. So when you import CSV file in this application, they would by default set everything as text. Okay, but this is where I want to click onto the survey table. Okay, maybe I think the record ID, so we can change it to integer. Month is, we can go into integer. Day, we can go into integer. Years. Plot ID is also integer. Species ID is actually text because it's like AB, MA, DC. We have sex is M and F, so it's text. We have hind foot length. Real is a real number. Weight, it can be integer or it can be real number. Once you click OK, nothing much happened, but it's just a way for us to tell the system what each column, what are the types of each column. All right, but we are not going to do that for today. We're going to work with the SQLite database that is already part of our data folder that we downloaded just now. It's simply because I have gone through the linking of different tables, and this is just a small example to show you can actually import your CSV file into a database like that, and you use some of the advantage of SQL language or some of the advantage of SQL database to manage your data, even if you initially only store your data in CSV format. All right, so everyone all good? It's an example only. So now we open the database. We go to the data folder that we downloaded just now. And we'll see portal memos.sqlite. Okay, and we click open it. Do you want to save the changes? Yes, no, maybe so. Okay. So now we are in the portals memo.sqlite database. Again, you can see that there are three tables, the three tables that we have always been working on. We can go to browse data. In browse data, we can see, we can have a look at how does each of the data table look like. This is for plots. We can change it to surveys. It will be the super familiar ones. Right? But of course, we are not just going to use this browser and look at the data and that's about it. We are going to do the same thing that we have been doing using Python actually. Filtering data, subsetting data. We will look at some aggregates. And I hope that we have enough time by the end of these sessions to show you how actually we can use Python. We can ask Python to talk to, yes, how may I help you? Oh, yeah. And we'll use it again, not as a point and click kind of applications. We would use the SQL language, SQL language to do so. Because with language, like with scripting language, again, as I say, we can apply the same scripts to all the other database, for example. We can also use the scripting language to do the same things over and over again without having to do the point and click over and over again. And with the SQL language, with a script, we know that we're in a good shape. We know that we can tell someone else, this is what I've done to the database. Now, the other good things about having a database, we essentially hand over the control of our CSV files to our managers. And our managers are supposed to protect the data from being altered. So, and that is why when we use SQL language, that is why the Q, okay, the Q is for, it says queries. What we do is queries the database. We never do the altering at all. I mean, we can use the SQL language to do altering, but the philosophy is that the database managers is going to protect the data. If I want to retrieve something out of the database, I would use the SQL language. I would do it. I would tell my database manager, okay, please have a subset of these sets, this data. And my database manager gonna do that, create a new copy, give me an output. So the data tables within the database is untouched in a way that when we do subsetting, we won't be accidentally assign it to our raw data or something like that. When we do subsetting of data, we won't be accidentally storing the subsetted table into our raw data, our original data. So it is very safe, and that is probably also why a lot of data security problems occur when in the database, and is the safest way of storing our data among what we learn using spreadsheet, using CSV. Using a database like this is the safest way to store our data, at least from what we learned so far. All right, so we are essentially going to do this very similar things as what we've done in Python. So I'm going a little bit quick, but SQL language is very easy to understand. It uses keywords that it feels like a natural language. And we will start to introduce them one by one. All right. Select is the most important part of SQL. Select year from surveys. This means please give me the year column of the surveys table. Select the year column out of the surveys table and give me an output. You can do a command enter, control enter, and you can execute this stretch of SQL code script. All right. If I want to select, we can also choose multiple column. We just need to do comma, month, day from surveys. And if we execute it, you'll see that the output will be year, month, day. Right? Simple language. easy to understand. You realize that I capitalize all my selects, I capitalize all my from, and I have two lines that in this language, in this script, but you actually don't need any of that. So SQL is case insensitive. So you can do this. Year, month, day, from, surveys, and SQL will still return the same result. Okay, this is like the most amazing part of it, but don't abuse it. Okay, don't abuse it. In order to make our queries readable, we generally do what I did just now. Okay, we capitalize all of our the keywords, and for all the others, we will just use lowercase day. And so select something, we consider that as one clause. And so we have these unspoken rules that we have one clause per line. So from survey, we'll put it in the second line. Okay, again, spacing has nothing to do with, so the script doesn't care how much you space. You can put a lot of space here and it will still return the same result to you. All right? So that is one magical part about SQL. Okay, we can use wildcard. Wildcard is asterisk. This means select all the columns from surveys table, and it will return us the huge table. Okay. Now we can actually also use the select command to do some calculations. All right, we have year. Say for example, select year, month, day. And the weight, if you look at the output here, the weights looks like they are in gram. Say for example, I'm interested in weight in kilogram instead. That would be weight divided by 1000, right? Okay. And we will have an output that has our weight divided by 1000. Okay. Sorry? I just assumed that. It might be in pound, but yeah. All right. So you may say that, wait, but this fourth column looks a little bit ugly. Weight divided by 1000. Okay, can we do something else about it? In fact, we can. We can actually use an alias as weight divided by 1000 as weight underscore kg, for example. And we will essentially rename our weight kg. Our weight divided by 1000 into weight underscore kg. Of course, it doesn't need to be calculations. Day, if you don't like that is being called day, you can convert it to, I don't know, ABC. Okay, yeah. Then you will get a column names with an ABC in your output. Okay. Now, we know how to select the columns, the attributes. We would also want to select a subset of rows. There's not as fancy as like Python, we can choose first row to 100 row, but we can use a where keyword to do filtering. Okay. Say for example, I'm only interested in year equals to 2000 or 2002. So I will select this bunch of things from the surveys table where year equals to 2000. a little bit different. As you can see, for Python, we need double equal sign. In SQL, equal means equal. Okay, one equal sign in Python it means a sign, but over here, one equal sign means equal. All right. And once we do a filter, we can see that our output has only 2002 data from 2002. Okay, for characters, it would be the same thing. Species ID equal to, we need to have the quotes. You can do double quotes or single quotes. Again, it doesn't matter. We have, what's it, DM? Yeah. Okay. Then we will have, oh, okay. So even if your filtering criteria is not part of the, it's not in part of the select, you can do that. It's just that there's no way for you to validate whether or not you are doing the right thing, right? So maybe we can add an additional species here. Wait, species ID, right? Yeah. And then we'll have a species ID column here, and we can see, we can validate that, well, whatever we just did was correct. Select from where. Now we can also do multiple filtering arguments. For example, we want year to be equal to 2002 and, okay, the keyword is and. Yeah, no longer the and sign. This wouldn't work, and this would work. All right, we have 309 rows coming back here. Now, what if I want species ID equals to DM, DO, and yeah, DM, DO, and I don't know what's the example, but 1 second. Bless you. Yeah, DM, DO, and DS. Okay, one way is we do this. Species ID equals to DM, or species ID equals to DO, or species ID equals to DC, LDS, I think. Yeah. All right. Then this will return all the DM, DS, all rows with the species ID with DM, DS, and DO somewhere. Okay. But it's a lot to talk about, right? Species ID equals to DM, DO, DS. You have to type so much of it. Another very good way, very cool way of doing it is to use species ID in bracket DM, DO, and DS. All right, and this would return the same result as well. So this is how you choose multiple value. You choose that you want multiple value for your filtering criteria. Like in Python, there's always three magical logical operators that we should know: and, or, and not. So we can also use not here. You can put not in front here. It will give you this result 18659 rows. We can also put not in front of our in, not in this bunch of things, and it will give the same result. All right. Also, species ID equals to dm. Back to species ID equals to dm. We can choose to say where not species ID equals to dm, or we can use the exclamation sign in front of our equal sign to represent not equal to. Okay, and they will both give the same result as well. All right, are we good? Too fast, too slow? Oh, good, okay. Now we'll do some sorting. Okay, I'll destroy these queries. We'll do some sorting. Let's look at the species table. Select everything from species table. Okay, so say for example, I want to sort my table using genus. I want it from A to Z. I think it's already A to Z. No, not really. Yeah, there are some P here and some C in between. Okay, so we can select everything from species table, order by genus. By default, is ascending order. So you can see that now our genus columns is from A to Z. There are some species that has same genus name, but different species name. Say now I want to order them by two variables, two attributes instead of one. We can also do that. We can order by genus, species. All right. There will not be much changes because I think when you order by genus, it's already the species is already in the alphabetical order. But we can change the order. We can change it to descending orders from Z to A, and that's how you do it. You add a descending DESC in the behind the variables that you want. So for genus, you can choose to add ASC for ascending. I mean, it's optional because by default, when you order by something, it's ascending order. All right, and you have something like this. That is sorting. And let's have a little exercise. Challenge. Okay, let's try to do this. Green, blue sticky when you're done. Red sticky when you having issues.
I was like, why is this not working? This should work. That's probably what's me, but Python lets you do more specialized. So you're going to yeah, it's cool. A couple things are they're fancy. Like I don't know how to see plots. Yeah. I don't know. I guess it's I don't know. But I think that might be yeah, that's true. It's a might be nice if I want. Different samples from multiple types of databases. My data or one was like
Oh, well. Sometimes.
I think this is a lot of data. So right now,
Just now, not sure, maybe. Just now.
All right. Thank you.
Okay, I need a volunteer. What should I select again? Come on, say something so that we can have a break. I know everyone is already having a break, but yes.
So do you need a volunteer?
Yeah. Yeah.
What am I doing?
The challenge problem. How do you do it?
Or just tell you?
Yeah.
All right, so we want to select the 3 date things, so we can select year, comma, month, comma, day.
All right.
We also want to select the species ID.
Yep.
So also the weight.
Weight.
In kilograms, so weight divided by 1,000 as kg.
Weight times per kg.
From surveys.
From surveys.
Then your line, say where.
Where?
Only from 1999, so where where year equals
1999.
ordered by species ID.
Species ID ascending. All right, that's great. Yeah, that's what we want, because now you can see that once we sort, we actually have the now value as the first, so as the smallest value, and then slowly we go into A, B, and C, and D, and E, all the way down to Z. One thing that is a little bit annoying for SQL is that there is an order of execution. If, say, for example, we choose to order it first before we do the filtering using where, it will throw an error to you. It will say syntax error. Okay, so the structure is always select from where order by. Okay, so we'll have 10 minutes break. Yeah. Yeah, you're already having a break.
small thing.
Probably not.
Yeah.
Thank you. I'm just like moving this like it doesn't scale you. It depends on I've been trained. This is a new undergraduate training. It's just like, is what training on Friday again? Like, I was like, do you really want to do that? She's like, yeah. Okay. That's fine. I can make it work. I was like, oh. Yeah, I can do that. Yeah, exactly. We drive. It's up north side drive. We drive because like I mean, it's like, oh, it's only 2 miles, but I'm like, and it's like walking, that's a lot of time. And like, also this is without like, this is hard, it's really hard to cross. This is the highway, and there is a bridge, but like, there's on-ramps and off-ramps. So these. Oh yeah, okay, nice. I'm like, I'm right north of the 72nd. So near the. So we're not far. But it's far enough that. Yeah. Yeah, no, it was hard to find. I lived here 1 year before my husband died, and then we moved here. So like in the yards here, I lived here. And that helped us figure out like what areas we like. Oh yeah.
Okay. All right, let's resume. So we have done selecting columns, filtering rows, we have sorts. Now we can do a little bit of what we have done in Python as well. We can do aggregation. Some of the aggregations like count, like sum, mean, max. We can also use SQL to do it. So how do we do it? We can say count. Select count everything. Okay, from surveys. Guess what the output is going to be? Number of rows only. Yeah. So this magical number 35549. All right. So it will return us a number, like the number of cases. Count is like count of the number of, because we are counting asterisks, we are counting everything in a row. So there will be 35,000 row in this case. Right, we can also say add up all the weights, sum weight. All right, and it will give us a huge number. We can take average So if you are so used to other language, you realize that you might do this. And you see that the mean is in purple color. No such function. All right, no such function as mean. So for SQL, it's gonna be average. Also not true. Yeah, it's in AVG. Okay, it's a little bit of a weird choice, but AVG is how you take mean value or average value of a certain column that you want. In this case, it means that take all the hindfoot length, take the average of them. But when we do aggregates like this, it's not fun to get a one value return. Usually we're interested in, I don't know, among the female, male, how heavy they are and things like that. And in Python, what kind of function would you use to say, okay, group the information, group the aggregates according to, well, it's grouped by. Okay, group by. Okay, when you group by a certain attribute, and then do the count, sum up the weight, and take the average value of the hindfoot length. In this case, for example, we use sex. Again, you can always group by something that is not selected. You can always do anything. You can use filter. You can do anything. You can order by anything without selecting them. But it will be confusing, like what's going on here. So it would be a better idea to select sex in this case as well. All right, then we'll have, so when we select, when we do aggregates like that, no value is recognized by the by SQLite in this case. But later on, we'll have some examples to show you how null values can be ignored when you use it on other occasions. Okay, we can choose to not just group by sex, not just group by one factor. We can also group by other factor like species ID. And of course, it would be a better idea if you have a species ID. Sorry? Oh, okay. Thank you. Yeah. Okay. And then we will have, say we have now sex, now species ID. There are actually 763 of them. None of them has weight, and none of them has hindfoot length. Things like that can happen. All right, so again, one more example on this. We want to look at what would you do when you want to look at what's the frequency of each species? What would you select? Well, we're interested in species ID, so you will select the species ID. And because we want to know the frequency is like count, right? Count of, it can be everything, because we will eventually group by the species ID. From surveys, group by species ID. All right, then you will have all of them. So now species ID, 763 of them. For species ID with AB, 303 of them. We can choose to order, we can sort according to the aggregated value. So in this case, it will be ordered by count asterisk. It looks a little bit inelegant, so maybe you can put aliases of something as well. So say for example, you can choose to alias it into count, and then we can use the alias here. That would be order by count. All right, this would work too. So once you alias it, you can use the aliases in other clauses. In this case, it's not so cool. We have a bunch of ones, two, low frequency species. I'm not very interested in them. Let's say I'm only interested in maybe those that is above the count number above 1,000. All right, what would you do? Which one of the clauses would you use? Keywords would you use? Where? Okay. So you can do a where count larger or equal to 1,000. It's a syntax error. Why? Yeah, the order of execution. Yeah, where is usually very near from. Right, select from where order by. So where should be in after from. Misuse of aggregate. No, turns out you cannot do that too. Yeah, because it's only after we mentioned that the count should be larger than or equals to 100. Only then you say that, oh, we should group by species ID. That's not quite. That means like the SQLite wouldn't even know what to group by, how to aggregate this, and you already tell them to filter according to this particular criteria. Okay. So what about we move where to after group by? Maybe it will work. Nope, don't work either. All right, seems like where loves from, so where has to come after from. What can we do? Turns out we have another keyword for this. That is having. All right. When we want to filter according to aggregates, we use having. And the having comes after group by. Where comes before group by. All right. So this case, where we will have an additional group by following by having. But having doesn't need to work only with how do you call it, with the aggregates. We can actually over here say that having species ID not equal to DM. All right. In this case, the having is functioning exactly like where. Okay. But it's only when we want to filter according to an aggregate that we use having. We have to use the having to filter. All right. If it's something else, you can use having. You can use where up here, and it will produce exactly the same result. All right. Sorry? The result just now was 47 rows. Without the DM, if you look at the well, DM is the most abundant one with about 10,000 counts. Yeah, don't have DM. So if we remove this, you will have 49 rows, which is quite interesting. When you have a filter, so when we say, wait, let's go back. When we say species ID is not equal to DM, 47 rows, right? But when we remove this filtering criteria, when we remove this filtering criteria, we have 49 rows instead. Something is weird. And there's no ghost here. Okay, what happened? Any suggestion? When we look at the 49 rows, we have DM in it. DM is the last one, in fact. And we have an additional row that says now. Now 763 count. But once we have the filter, we're down to 47 rows. And if you scroll through it, 763, we no longer have that particular entry. We don't have now entry anymore. All right, and this is the behavior of now in SQL. Once we do something about filtering, now will disappear. Now is nothing. Now is nothingness. So once you create a filtering criteria, now just suddenly would disappear. There will be non-existence in our output anymore. All right, we'll go into the behavior a little bit closer. In this case, let's look at sex and mean weight. Okay, from surveys. Again, if we simply group by sex, oh, what happened? Oh, well, average. AVG. Okay, we'll have three now, female and male, and the corresponding average weight. Now, let's say I'm not interested in one of them where sex is not equal to male. All right. Again, now disappear. All right. When we say sex is not equals to male, we expect to have now and female, but no, now actually disappear. Okay, now is nothing again. And once you have a filtering criteria, SQL, the DBMS, the database management system, usually ignore all the now values. Okay, and now is not something that you can refer to. You cannot say sex equals to now and hope that it would work. It won't. There would be no result in this case. You cannot say where sex is not equals to now. When you do this, you also get 0 row. All right, now is something like a Terminator. It kills everything. Am I right? No, I don't know. Okay, so in order to refer to now, we need to use additional keywords. In this case, is not now. All right, then we will have female and male. Wait, everyone else is computer is behaving the same as me, right? Okay. Yeah. Well, if there's is not now, there is also is now. All right. And then this is how we refer to null value or missing value sometimes. Okay. We have to use an extra keywords is or is not to refer to null value. You cannot say whether or not you are equal to null or not. Right? And that's why it is very important that when we do data filtering, we need to take into account that there may be missing values. And this missing value will be stored as null. And when it's stored as null, we need to handle it in an extra way. All right. So that's the aggregates. Are we all good so far? Not to me. Okay. All right. I'll go into the next section, which is the more important part of database. Since database has multiple tables, when we need them, say for example in this case, if we are in a survey table, for some reason we are interested in how the genus name or the species name or the specific animals behave, then we will need to join table together. Again, we learned about join just now from Ashwin's talk about Python. So since joining tables is one of the very important part of database, there is also specific keywords to do joining table. But let's try not using the keyword first. How would you join two tables together? Well, you join survey table and plot table. You want to add additional column in survey table such that it reflects the information of the particular plot. How would you do that? You want to match the plot ID in the survey table with the plot ID from the plot table. Right? One way we can do it is we can select everything from surveys and from plots. Okay, where surveys.plot underscore ID. So this is how we refer to the plot ID in the surveys table. That's like surveys.plot ID must be equal to plots.plot ID. Does it work? So if you look at the new table, now we have, so the first part of the new table is coming from survey, and the second part of the table is coming from the plot table. All right, and you can see that plot ID is always matching with plot ID. And then we have an additional columns of plot type. Again, this is quite cumbersome for to combine join table like that, and this is not very intuitive. So SQL come up with additional keywords. Guess what? Join. All right, join. So we can select everything from surveys and join it with plots table. if you ask SQL to join it like this, SQL will be like, I don't know what you are talking about. I'm just going to join everything up. And the output is ugly. So we need to tell SQL how to join this up. And how to join this up, we come up with a criteria and says on the same thing. Surveys.plotID equals to plots.plotID. All right. That also allows you to join the two tables together. But this is quite stupid, sorry.
Why is that easy?
Yeah, why is that easier, right? It's not easier. It's just, it sounds more human that you join two tables together. But there's something that makes it a little bit easier. It's quite stupid that both sides has the same column name, plot ID and plot ID. Why can't we just do something about it and tell them, okay, you can look into the table and look at the plot ID and join them up together. And that's why there's another keywords that is join using. And in join using, we can put up a parenthesis and say plot ID. Okay. Plot underscore ID. It's only because both tables have exactly the same column name and referring to the same thing. We can only then we can use using. All right. And another good thing about using is you see that the plot ID coming from the plot columns now disappear. From the plot table now disappear. Okay. So that is joining to us. No. Let's try something. Challenge again. Find out the average weights and hind foot length of each taxa. All right, taxa in this case means the type of animals. That will be rodents, reptiles, and birds. Taxa. Weight. Hind foot length. Taxa. So your table should roughly look like that.
This is the one where it looks big.
Information of text size in species. Okay.
Oh, never mind. I have to go. That's why I was saying. What did you say? What if you put the average? Average. Because you drove flash. I guess so. Like reptile maybe.
It probably is not a good idea to use average weight of XR because the experiment, the survey is they only want to look at so they only weight. Yeah. Yeah. Except the
So in the study, it's
yeah, only the rulers has values weights and height. Because they only care about rulers. They don't care about other.
So it should be 3 notes.
Yeah, 3 notes and one group.
They only get it. Yeah, that would mean, I don't know why. No, oh yeah, man.
Okay, let's do this. So what should I select? Yeah, first because I'm interested in Texar, so I will select Texar as well. Yeah, and then average AVG, yes, that's right. Weight and average hind foot length. From surveys, yes. Join with what? Oh, species, yeah. Using species ID. All right. Oh yeah. Oh yeah. Yeah, because I didn't group by Texar, that's why I only got one row. I'm sorry. Okay, yeah, this should be the result. It wasn't a good idea because it's a project that cares about mammals. That's why the SQLite name is Portal Mammals. But then they also don't measure rabbits, so I'm not too sure why. Okay, let's say I change this to count. Then this would look a little bit nicer. Yeah. All right. Now, how do we sort this table then? If we want to sort based on the count. We'll just order by. Count. All right, and that will work. What if I want to know Texar with more than 100 count? Sorry? Add what? After group by, I can add what? Where? Okay, where count star greater than 100. And you get it. That's because after goodbye, you need to use a having. Yeah, after goodbye, you need to use a having. All right, then we will have the filter in place. Okay. So the rest of about half an hour or so, I would want to talk about, since we have been talking about Python in the afternoon, so I would want to demonstrate how you can actually use Python to access SQL database. And that can be in the workflow of a lot of people, because sometimes we actually have access to some of this like a huge public database, and you would want to use Python to directly communicate with the database. So essentially, you're using Python and say, okay, I have this query script I'm asking from the database, and the database will produce an output, for example, like this, and give me the data table. And then I can use that, and it will be a data frame in Python, and then I can use that to do additional analysis from it. All right, so hope this would be in maybe some of us our workflow, and I think it would be nice to tie the Python and SQL up and see why it probably is a good idea to learn multiple languages, learn multiple way of doing the same thing. All right, because when your database is huge, you wouldn't be able to just use read underscore CSV and put everything into the Python programs or something like that. So what you want to do is you do a query, you reduce the amount of data before you pull it into Python and do the data analysis. All right, so for this part of the demonstration, I will need my Jupyter notebook. Okay. Oh, okay. So I create a new Python notebook. The very familiar interface that you have been staring at for at least the past 24 hours. All right, so in order for Python to communicate, in this case is SQLite. So of course, there are other packages that deal with other type of database. In this case is SQLite. I would import SQLite 3. So this is one of the package that I would need to communicate with SQLite database. Because I'm using pandas, I will need to import pandas as well. Okay. Now, as with most of the way programming language communicate with data file, communicate with database, not really data file, but communicate with a particular text file sometimes. The first thing that the programs want to do is to establish a connection with something. All right, so we declare an object that is a connection, or con in this case. If you don't like con, you can do double N. And under the SQLite 3 package, there's this function called connect. So we want to establish a connection with the database that we were working on. For me, my SQLite file is at data folder / portal _ memos.sqlite. And so I run it like this. So for many of us, it might be in other folders. So if you have a problem communicating with your SQLite database, you can put a red sticky or put up your hand. Oh, sorry.
If it doesn't connect, you get an error message.
I think so. Do you get an error message?
No.
No.
So
Should be
that's
fine.
right.
Yeah.
I think the SQLite is depending on other databases.
Yeah, that is painful. Yeah. Are we all good? Now, in order to get data from database, we need to speak other language. In this case, we need to speak SQL to SQLite so that we can pull data out from them. All right, that's right. That's why we have to create a query. A query is a very long bunch of string. Okay. So what goes into query? Okay, well, let's think about a story to tell. My boss wants me to look at different plot type and the relationship of the different plot type with the weight and the hind foot length of the animals inside it. All right? Mean weight and hind foot length of each plot type. All right, what do we do? Select plot type. If you remember how our plot table look like, the plot table is essentially only plot ID and plot type. So we want to know the plot type. So select plot type. That's what we're interested in. We're also interested in mean weight. That would be AVG weight as, well, I will just call it weight or mean weight. I also want to know the mean hind foot length. That will be AVG hind foot length. I call it S mean. I'm lazy to type, so I will do HF length. The major issue with not just Jupyter Notebook, but in general, most of the programming languages in general, you cannot do enter like this and continue to do the typing because the Python will think that you're talking gibberish to them. So unfortunately, we'll have to type all our query in one line like this, instead of what we were used to that just now, where we have one clause per line. So where do we pull our data from? From two tables, plot, okay. From, sorry? And surveys. And how do we do that? Join, okay. Join surveys. And then how do we tell them what to match? Using, okay. Using plot ID. Can we? I don't know how. Oh, you mean I can do that? I have, because it changed color, that's why. Have backslash. Okay, backslash, enter. Oh, great. So yeah.
The best way would be to think of triple quote. Like, declare thing with
3 double quotes. Okay, let's try this out, okay? Without the backslash or with the backslash? Without the backslash. Oh, okay. All right, you learn something new every day. Oh, okay. So if you use triple double quote, apparently you can do multi-line entry like this. But we'll see, we'll see. Are we done with the query yet? What else do we need? Group by, all right. Group by the plot type. All right, to test if it works, we can do a query, we can check what goes into query and shift enter. Yeah, it looks like it might work. Yeah. Yeah, we will know. We will know very soon. For FYI, there's a backslash n here. Backslash n here in text file usually means new line. Okay, essentially an enter when we do our when we key in, essentially behaving the same thing as an enter in our notebook or notepad. Right? Everyone happy with this quote? Now, here comes the exciting part. Okay, so I have mean by plot type. That's our variables. Pandas has a function. So pandas has a function that is called read underscore SQL query. Once you type pandas dot, you tap do a tab, press on your tab, yeah, and then it will pop out all the possible functions under the pandas package. Not just functions, right? There's also attributes and whatnot. All right, read underscore SQL underscore query. Now we put in our query here. Does this make sense to everyone? Sorry?
Can you scroll up?
Oh. Yeah. And if everything works, sorry? Oh yeah, oops, yeah. That's right. Yeah. Not only you put in the query, you also need to tell the function where do they connect to, who do they talk to. Remember, we establish a connection with the SQLite, our SQLite file just now. Oh, down there, we need to tell the functions, we need to tell pandas who do we talk to as well, not just giving them the query only. Okay, that's why we need to add an additional argument that's referring to our connection. All right, are we good? Now, yay, it works. I've been spending the whole day on that. Okay. Okay. Yeah, once you use the triple quote on our query, we can actually do multiple line breaking. All right, that looks like what we did just now using the DB browser, and it will still work. All right. Nope. Nope. No.
My numbers are mine's. Data set, data is data. Yeah.
Oh, because your
I don't know if that's it, but
try to use the
I don't know.
Yeah, I don't want to make it so too many extra spaces. Okay, so now it's where I wanted to see, but it's not in the same.
Are you using the one that download? You will need to work with the portal underscore memo SQLite that is downloaded from just now the link that I set up there. You cannot use the one that you use for Python. It's a little.
I'm not sure what you're saying.
No, so yeah, so yesterday download one set that also have a model.
So this is one item, yeah. Oh, but now you've got it. Yeah, you gotta use the whole.
Yeah, it's just
Actually, just move your file to desktop. Really good. She was referencing the file from yesterday. Oh, but you didn't get the seniors.
I'm still not sure if that's desktop. I mean, it'd be.
But you weren't before.
I'm sure he wants to. He was talking about it. Yeah, I just had.
Let's get rid of everything.
Yeah, mine's my method before ads.
I think he was talking about it.
There goes. It did say before ads. Yeah.
Is it okay?
We didn't know which ads. Of that, right, maybe it's, you could change it back.
So
I think you need to ask it.
okay. Okay. So this is how we talk to our. This is how we talk to SQLite and ask them to return a table. And now our mean by plot type is a pandas data frame. For the very last part, I'm gonna demonstrate a little bit of data, a little bit more of data visualizations, and I don't think we ever have enough time to finish this. But it's to motivate you to look at some of our lesson plans. I'm introducing these things called ggplot. I myself is using R a lot more than Python, and ggplot is a big hit in R, and it makes plotting easy. And I want to show you how I will plot this out as a bar plot. All right. I will import another package called plot9. Right. The problem with plot9 is it has 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe 8. Yeah, 8 characters. Too troublesome. So I declare a short form for it. I call it import plot9 as p9. Did we talk about it before?
I don't know if everyone has content.
Oh no. Okay. Well. Yeah. Yeah. Okay.
I think the lesson setup page has instructions how to install.
Oh, I see. Okay. That's interesting. Do you know how to? Okay. Data carpentry. Lessons, ecology lesson, data analysis and visualization in Python. Setup on the top tab. Top. Okay. Install the workshop packages. Anaconda. Download plotting. Okay, from the terminal. That's a problem. The Windows folk, I don't know how to. Okay, there's an Anaconda prompt. Okay. So for the Mac folks and the Linux folk, there's something called terminal that you can fire up. Okay. And using the terminal, we can actually copy and paste these things. It says, or you can type it out, it's conda. Conda is basically it's like a package of things that include Jupyter Notebook, including Pythons and everything, and it helps us to manage all of our Python packages. Right? In this case, we want to install -c conda forge. -c conda forge is basically telling Anaconda where to find the package. And finally, we want to install this package called Cloud9. Why do I have this problem? Oh. Well, you guys don't have this problem, right? If you were to type this out. No, for you guys, you should.
Okay, so
Sorry.
for Mac users, you're opening your terminal. That terminal already has a bunch of text in it. Then just click on shell on the top and user.
Far big. Fine. Yeah. So the PC folks, there's something called yeah. So we run that. Okay. Yeah. Solving environments is good. Yeah. So for PC folks, you can search for Anaconda prompt. The Anaconda is it's a Cloud9 that so Python comes with a package. It's a package. And that's a package. So Cloud9 is also a package that helps us to plot really cool looking plots.
So it's a solving environment.
Okay.
Yeah.
Actually, maybe other ways to install packages. I think that Amazon has some graphical package. I haven't used it, so I just can't recommend it. No, this is open source purpose. Yeah, you can just have it. Or So any sort of type RCS so this is and you type conda space install space space conda for
Okay, so just remember that in general, this is not always how you will install Python packages, but Conda is generally will install most Python packages. You can just type in Conda install package name. Sometimes you will also need to specify -c Conda. And if you go to any packages website and you look at the install instructions, most of them will be like Conda install package or pip install package. Pip is another program that stands for pip installs packages. It's a recursive acronym. So it's either pip install package name or Conda install package. Both of those are packages to help you install packages.
All right, we're running out of time. But I just want to show you inside our lesson plan, we'll go into details about how to go about doing this ggplot. So I will show you, well, how we can do some nicer looking graphs with some easier code than the matplotlibs that remember we do something like dot plot parentheses. All right. P9.ggplot. I'll do a bit of demonstrations and then we will close this workshop up. So bear with us. ggplot. I have data equals to mean by plot type. So mean by plot type. What ggplot wants to have is the data frame that we are working on, and there's this thing called mapping. Mapping requires an argument of aesthetic. Okay, P9.aesthetic. AES stands for aesthetic. So aesthetic is where we define what should go into the x-axis and what should go into the y-axis in our plot. In this case, my x is gonna be plot type. And my y is gonna be the mean weight. Say for example, I'm only interested in mean weight here. Okay. If we run this, I go into name error. Oh, yeah. Remember how we refer to columns in Python? It always comes with quote unquote. All right. So our plot type and mean weight is referring to the particular column. So we need to do a plot quote unquote. There are some warning messages. I get a graph with nothing. So the first function is a bunch of very wordy function. Is called ggplot, right? ggplot establish a base drawing board, a canvas board or canvas basically, that already has all this information on x-axis and y-axis. X-axis will be plot type and y-axis will be mean weight. But it's not gonna do anything until you define more, you mention more, think about it. You add more layer on it. So I'm gonna say this is my plot. So I assign it to a variable Scott plot. All right. Then I want to add one more layer onto the plot. And this layer would call geom. It's p9.geom. Geom, I think the closest things it means is geometry. It's basically defining what do you want to put onto the canvas? What do you want to add onto the drawing board? In this case, if you go to if you tap on tab, there will be a lot of choices of geometries that you can add onto this drawing board. Say I'm interested in bar plot, so I go to geom_bar. All right, it's a function. That's why we have a parenthesis, open and close. And then I'll see if it plots anything. Okay, that is not fun. Not cool. Let's forget about bar plot. There's a little bit more explanation behind it, but we are running out of time. Let's. Oh, the variable would be the plot type. Plot type is also a variable, right? In the data frame. Okay. Yeah, and the mean weights is another one. All right. Yeah. At least there's something to show you. Yeah. I mean, if you're interested in knowing why geom_bar doesn't work, we can talk about it later. But yeah. So say for example, if I were to plot a point, then you can see the 5 different plot types, and the points would represent the what's that? The mean weight. Yeah, right. And there's a bunch of cool functions. So in the aesthetic function, we can add additional things. Color. We can say that, okay, for each of the different plot type, I want different color. So I can ask it to, within the aesthetic, I can have a additional argument called color equals to plot type. So I'm asking ggplot function, okay, I don't know what color you want to choose, but for each of the different type of plot type, assign a different color on it. I hope it works. Nope, it doesn't. Color? Yeah. You have to spell color instead of COL. The person who wrote ggplot is from New Zealand, and he decided that both types of color work. Yeah, both types of color spelling works. All right, it's a little bit of motivations for you. It's a pretty easy package to plot these kind of things. We can have some. You can control color. You can also control like how the points should look like based on the different factors that we put in. Unfortunately, we don't really have time to go through this, but I would like to do a short closing about our workshop. before we go. Okay, unfortunately we have to close the workshop like this, but feel free to talk to me if you have time later, if you want to know a lot more about doing visualizations using Python and using ggplot. Please fill in the post-workshop survey. The link is on its way to the Etherpad in a few seconds. Okay. Post-workshop survey. Yeah. Please fill in the post-workshop survey because it will really help us in knowing what's gone right, what's gone wrong, are we doing the right thing, and how would we be able to improve the data carpentry workshop, especially because this is an open source lesson plans, and things are changing, things are slowly improving. We get feedback from workshop participants like you, and we hope we can do a better job next time. Back to the PowerPoint. The survey link is also in the workshop webpage. If you go to the workshop webpage, there's a section called survey. We hope that you would be able to access our survey, do the survey. I think we will also be sending email to ask you to fill in the survey in the next few days as well. Now, it can be painful. Sometimes you probably don't know, like, is it worth it to do more about to actually transition to Python or transition to other software tools in dealing with our data? And this is a very good chart. Basically, it means that the more often you do the task, the more you benefit out of these things. And right now, you may have forget quite a little bit of things from the Python lessons, from the SQL lessons, from what we talk about database, but it's all about how often you do it and how often you so-called practice it. So we hope that our workshop can give you a head start, or push you a little bit towards trying to incorporate all these skills into our research workflow, because that seems to be the future for us. So that's about it. And to wrap this up again, workshop website, it looks pretty easy to remember. The Etherpad will stay forever, almost forever. Yeah, in case it flickers again. So yeah. The Etherpad will stay forever. If you need to refer to something, feel free to go back to the Etherpad. Only problem is no one to chat with you. But we also have lesson plans. Lesson plans is in www.datacarpentry.org/lessons. And that's where most of our lessons plans has based on. And in fact, there are more information and more explanations in the lessons. So feel free to go there and take a look and refer back if you forget about something and you want to do it. Also, the lessons are open source. That means anyone can contribute to it. There's link when you go to the lessons, you can say improve this page. And that brings you to the GitHub page, and you can file issues. You think that, no, this section is not useful, not good to learning, how you can improve it. Feel free to go there and put in your thoughts. And even if you think that there are bugs in the lesson plans, please feel free to go there and join us in improving the lesson plan. The whole idea of carpentries is also, we want to convey a message that anyone can be like me, standing in front, talking about Python, talking about SQL, talking about spreadsheets, and it's all about. I'm very happy to be here, and I'm glad that you spend your time with me in this workshop, and I hope that we can help folks here to build up communities to help each other out on computing skills and data skills. And if you want to get involved in the data carpentry initiatives and the organizations, there's also a link called Get Involved, if I'm not wrong, in the workshop, in the website. So go check it out and see if we can do something similar in the future. I know AJ has been saying that like he hopes that like there is a workshop like this going on in the future, and I hope many of us who has gone through this would be able to help it out. I myself is running an R user group for the research scientists back in the University of Florida, and I feel like, yeah, I have always wanted to say this, get involved in some of these initiatives. I think we are really neat people, and we really hope that people can get involved in it, because you see the need. Everyone needs some sort of like computing skills and data skills, and you always feel like, I need help, but why is no one helping us? So hopefully we can get more and more of us to join in these kind of initiatives. So thank you very much. Is there anything to say, Ashwin? Yeah. All right. Thank you very much for having me here and having Ashwin here, I guess, to share our experience about learning some of these skills, Python, SQL, and learning data skills in general. Thank you very much. Oh, yes.